Hello friends, welcome to the tutorial series on network analysis made simple. In this tutorial, we shall solve gate questions on network reduction using equipotential concept. Friends, in this question, it is given that the identical resistances, each of 6 ohm, are connected along the edges of the cube as shown in figure. We are required to find the equivalent resistance RAB along the long diagonal A and B shown in figure. Friends, observe the given network. We know that A and B are supply terminals. Another 6 terminals are seen in the network and they are C, D, E, F, G and H in the given figure. These are the load terminals. First, let us check the load terminals C and D for their equipotentiality. Path resistance from C to A is equal to 6 ohm and from D to A also is equal to 6 ohm. Similarly, path resistance from C to B is equal to 6 ohm, 6 ohm and from D to B also is equal to 6 ohm, 6 ohm. Hence, points C and D are equipotential points. So, let us short them as shown in figure. Next, we shall check D and E for their equipotentiality. Path resistance from D to A is equal to 6 ohm and from E to A also is equal to 6 ohm. Similarly, path resistance from D to B is equal to 6 ohm, 6 ohm and from E to B also is equal to 6 ohm, 6 ohm. Hence, D and E are also equipotential points. So, let us short them as shown in figure. Let this shorted path from C to D to E be X as shown in figure. Friends, next we shall check the load points F and G for their equipotentiality. Path resistance from F to A is equal to 6 ohm, 6 ohm and from G to A also is equal to 6 ohm, 6 ohm. Similarly, path resistance from F to B is equal to 6 ohm and from G to B also is equal to 6 ohm. Hence, F and G are equipotential points. So, let us short them as shown in figure. Next, we shall check the load points G and H for their equipotentiality. Path resistance from G to A is equal to 6 ohm, 6 ohm and from H to A also is equal to 6 ohm, 6 ohm. Similarly, path resistance from G to B is equal to 6 ohm and from H to B also is equal to 6 ohm. Hence, load points G and H are equipotential points. So, let us short them as shown in figure. Let this shorted path from F to G to H be Y as shown in figure. Now, we can draw the reduced circuit. Friends, we find that between supply point A and the load point X or C, D, E, three resistances each of 6 ohm are connected in parallel and their equivalent is 6 divided by 3 equal to 2 ohm as shown in figure. Similarly, between the supply point B and the load point Y or F, G, H, another three resistances of 6 ohm each are connected in parallel and their equivalent is 6 divided by 3 equal to 2 ohm as shown in figure. Also, we find that between point X or C, D, E and load point Y or F, G, H, six resistances of 6 ohm each are connected in parallel. Two resistances from C to F and G, another two from D to F and H, and another two resistances from E to G and H. So, the equivalent of all the six resistances is 6 divided by 6 equal to 1 ohm as shown in figure. Finally, we find that 2 ohm and 1 ohm and 2 ohm are in series across A and B and their equivalent is 5 ohm. Hence, option B is the correct answer. Friends, note that if all the resistors connected along the edges of the cube are of, say, value R ohm, then equivalent resistance along the long diagonal A and B of the cube RAB is equal to 5 divided by 6 into R. Remember this relation. Since the value of R in our problem is 6 ohm, we got RAB is equal to 5 divided by 6 into 6 and is equal to 5 ohm. Hope it is clear to you. Friends, I am sure you have clearly understood the concept of identifying the equipotential points in the resistive networks. Hope this tutorial has kindled some of your thoughts and I hope you have enjoyed the presentation. In subsequent tutorials, we shall meet and solve some more interesting problems. Thank you for watching.